All right. Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 6, Notes 1. So we are going to be talking about scientific notation. Now, this might be something that you've done in science in the past, and it will definitely be something that you do in science in the future as well. So it's also very important in math, so we're going to kind of take a look at it to make sure we're ready for it in both kind of scenarios. So first of all, scientific notation is used to write numbers with decimal places in a more condensed form. So instead of writing out a bunch of zeros, then we can just write it into a condensed form. We also want to use base 10 to indicate how many places are missing. So we're going to be putting some sort of 10 raised to an exponent. And we're going to be kind of looking at why that is here, taking a look at a couple of these. So let's just go ahead and start by taking a look. So taking a look at number 1, we have 1,329,000,000. Okay, so what we're going to do is we basically want to have 3 to 4 digits. So what I'm going to do is I'm going to say, okay, well, the decimal point is at the end here. I want to move it to be there. When we're doing scientific notation, we want to have one number in front of the decimal. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So when I moved it 9 places, I'm just going to write that 9 down so I remember it. I ended up having 1.329. Okay, so 1.329, so that's going to go right here. Doesn't like me drawing 2's. So then I'm going to take that and I'm going to multiply it by 10, and I'm going to raise that 10 to the 9th power. Because what I want someone who's coming to look at this to be able to do is say, okay, I have this number and I need to move it right 10 places. So that's what this 10 to the 9th tells someone looking at it. Then eventually they will get that number up there. So taking a look at number 2. So number 2, we have a really, really small number. So we're going to write it to be easier with less zeros. So I'm going to take this decimal point and I want to bring it to between the 6 and the 8. So I'm going to do 1, 2, 3, 4, 5. So I'm moving it 5 places over. So I have 6.8, but the 6.8 needs to get smaller. So when I take my base 10, I need to raise it to the negative 5, okay? And now it's negative because I want people to know when they look at this that they need to move it to the left in order to get the decimal that I was given in number 2. So when I want to make it smaller, it's a negative. When I want to make it bigger, it's a positive. Now, taking a look at number 3, if you think about like a business, if you're watching the news, it'll say, oh yeah, Target lost, $3 billion in revenue after the Target fraud. Okay, well, $3 billion, they don't hit billion every single time. What they do is they round it to significant digits. So that's what we're going to do is we're going to take this number, and I'm actually just going to focus on 3 of the digits. So I want to make it 2.4, and I just want the 5. So since the 6 is 5 or greater, I'm going to round my 5 to be a 6. So that's what I'm going to be moving it to, okay? So let me make my line a little bit skinnier here. Oh, not an option. There we go. Okay. So then what I'm going to do is I'm going to move this to this decimal point right there. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. So I moved it 9 places to get it to this spot. So I've already rounded it, so now I can just do times 10 to the 9th power, okay? So that's my final answer for number 3. So now on number 4, I want to have a number before the decimal point. So I want to move my line so that the point, the dot, is between the 8 and the 9. So now I'm going to go ahead and do that. And let's just move my magical eye out of the way. Okay, so then what we're going to do is we're going to move this right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I moved it right 11 places. So that gave me 8.9, but I want to tell the person who looks at it that they need to make it a lot smaller. So I'm going to use that 10 to the negative 11th to tell them that. Okay, so now let's go ahead and let's take a look at the opposite way. So now we want to take and we want to convert it in the opposite direction. So what we're going to do here now is we are going to take 3.267 and we want to move the decimal point 5 places. Now remember that that 5, since it's positive, means we're going to get bigger. So we're going to move it to the right. So we're going to go 1, 2, 3, 4, 5. So any empty loop that I have, I'm going to put a 0 in it. So then I have 3, 2, 6, 7, 0, 0. Now we need to put our commas in it, which you do every 3 numbers. So then I'm going to have 326,700 as my answer for number 5. So for next one we have 4.567. And this time we have a negative 3, so they want us to move it left 3 places. So I'm going to go 1, 2, 3. Any empty decimal or any empty loop has a 0. So the decimal point is here, and then we're going to have 2 zeros, and then our 4, 5, 6, 7 is going to follow after that. Okay? Taking a look at number 7 now, we have 4.5. So then we need to move it right 7 places. We're going to do 1, 2, 3, 4, 5, 6, 7. Any empty loop needs to have a 0 in it. Okay, so then I have this 4 and 5, and then I have 1, 2, 3, 4, 5, 6 zeros. So then I'm going to have 3, 3. So it ends up being 45 million. Crazy how this number turned into 45 million. Pretty cool, huh? So next we're going to have 3.687, and that's 10 to the negative 8th. So that means we need to move it left 8 spots. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Any extra loop I'm going to fill in with a 0. So this is going to be a really teeny tiny number. We have 1, 2, 3, 4, 5, 6, 7 zeros before we even reach our number. And then we're going to write in our numbers. So that's 3, 6, 8, 7. So that's our final answer for number 8. So now what we're going to talk about is operations when things are in scientific notation. So when you are adding and subtracting, it's kind of like when we, back in Unit 3, when we talked about like terms, okay? So in order for us to add things in scientific notation, they have to have the same power of 10. And the same exponent. So if both of them have 10 to the third, then I can add them together. So if the exponents are the same, all you're going to do is add the numbers out front, and you're going to keep the exponents the same. Now let's say the exponents are different. Let's say you have 3.2 times 10 to the third plus 8.6 times 10 to the fourth. You cannot just add them together because they're not like terms. Just like in Unit 3, they have a different exponent. So what you're going to do is convert it into standard form, add or subtract those two numbers, and then you're going to take your answer and convert it back into standard form. So what we really like are when the exponents are the same, because if they're not, it's a little bit more work for us. So then when you're multiplying things in scientific notation, you need to multiply the coefficients in front of the powers of 10. So you're going to multiply the coefficients, and then again, just like in Unit 3, you're going to add the exponents of the power of 10. Because we're multiplying together and they have the same base, we're going to add those exponents. Then taking a look at dividing. So when we divide the coefficients in front of the powers of 10, okay, we're going to divide the two numbers, and then you're going to subtract. Same rules as Unit 3. When you divide things of like bases, you subtract the exponents. So you're going to subtract the exponents of the power of 10. So let's go ahead and let's take a look at this guy right here. So it says that we need to adjust the exponent as necessary. So here's what's really important where this is concerned. So the coefficient is greater than or equal to 1 and less than 10. So basically what we want to have is a number, some sort of number, a decimal point, and then we can have a couple more numbers. But the biggest point is that there's only one digit before the decimal point. That's really key, and that can sometimes get confusing when we do some of these operations with scientific notation. So let's go ahead and let's take a look at some of these operations. So taking a look at number 9. So for number 9, I see that I have 10 to the third and 10 to the third. So that means I can simply just add together. So what I'm going to do is going to take 0.37 and add 4.57. And when you add those two together, you get 4.94. Now, since we're adding, we're going to keep our exponents the same. So that's going to be times 10 to the third. So then now what we want to do is now we're looking at number 10 and we need to multiply. So what I'm going to start off by doing is multiplying the coefficient numbers. So I'm going to take 2.37 times 3.47. And when I multiply those two together, I get 8.22. Then I'm going to take times and then 10, and now I need to add the exponents. So I have 10 to the 4th times 10 to the 3rd. Okay, so that's going to give me 10 to the 7th. All right, let's see if it'll let me retry drawing that too. Much better. Okay, so let's take a look at number 11. So number 11, we're dividing. So I'm going to take 9.60 divided by 1.60, and that's going to give me 6.0. And now I need to subtract my exponents. So I have 10 to the 7th divided by 10 to the 4th. So when I'm going to subtract 7 and 4, and I get 10 to the 3rd. Now let's take a look at number 12. So for number 12, we don't have the same number. So that's where we need to convert it into standard form because we don't have the same exponents. So what I'm going to do is I'm going to move this right, 1, 2, 3, 4. And then for this one, I'm going to move it right, 1, 2, 3, 4, 5, 6. So let's go ahead and let's write out what numbers we have. So here we're going to have 4, 8, 2, and then it looks like we have 1, 2 zeros after that. Then we're going to subtract this off. Then I'm going to have 3, 4, 5, 1, 2, 3, 4 zeros after that. So then we're going to get this right here, okay? So now I can just go on my calculator and I can actually subtract those. So when I subtract those, I get negative 3,401,800. So I get 3,401,800. Again, I only need a couple significant digits. So what I'm going to do is I'm going to put my decimal point after the 3.4. So I'm going to kind of leave out these numbers here and pretend that they're zeros. So I'm going to go 1, 2, 3, 4, 5, 6. So I moved it 6 places. So I'm going to have negative 3.4, and then I'm going to do times 10 to the 1, 2, 3, to the 6th power. Okay, because I counted my loops. Again, this 6 is positive because we want whoever looks at it to move it right to make that bigger number. So let's go ahead and let's take a look at some more examples. So taking a look at this one right here. So we have 6.0 times 2.5. So I'm going to go ahead and multiply those together and I get 15. Times, and then we're going to add our exponents. 3 plus 2 is 5. Here's the problem, though, that we have here is 15 isn't that less than 10 that we talked about. So what I need to do is I actually need to take 15, and I need to move my decimal left another place. Okay, so it's going to be 1.5. So that's my goal is 1.5. And then this needs to go up one more. We're probably like, Miss Humbert, you moved it to the left. Why is it going up one more? Well, first of all, up here, we needed them to do 5 over that way, right? Well, now that we move the decimal place this way, we need them to go 6 to make up for the ground that we did when we moved it back that way. So it's all about opposites here. Okay, so this right here is our final answer for number 13. So now let's take a look at number 14. So for number 14, we're going to have 7.8 divided by 1.2, and that's going to give us 6.5. Times 10, now we need to subtract our exponents. So a lot of students do this one and they put just 10 to the first, and that's incorrect. Okay, so we're doing 10 to the third divided by 10 to the fourth. So that means we need to subtract 3 minus 4, which is negative 1. Okay? So then this right here is the final answer for number 14. So then 8.1 divided by 9.1 is going to give me 0.9 times, here we're going to have 10, negative 2 minus 2, which is negative 4. So here I need to have a number that's greater than 1. So then what I want to do is move it left one more, or sorry, right one more, I'm sorry. So then we're going to have 9.0. So then I need to make this a negative 5 to account for the fact that I moved it right one to get it 9.0. So then it needs to be 10 to the negative 5th in order to make up for that gap. Then, taking a look at number 16, let's start by simplifying out the bottom. So we have 6.48 times 10 to the 5th. Then, 2.4 times 1.8 is 4.32. Okay, then times 10 to the 4th times 10 to the negative 2. Since they're both on the bottom, we're still going to add those exponents, but it's going to be 4 plus a negative 2, which is 2. So my next step is to take 6.48 and divide 4.32. So that's going to give me 1.5, and then we're going to take that times 10 to the, now we're going to do 10 to the 5th divided by 10 to the 2nd. Subtract those exponents, and we're going to get 10 to the 3rd. So that's your final answer for number 16, and that concludes your note video. Thanks for listening.